Hello. This is an example of verifying a trig identity where you can work with the left side and the right side separately until they look the same. We will be using the identity 1 plus tangent squared theta equals secant squared theta in this problem. And so I am starting with the right-hand side of this identity, tangent squared theta over secant theta minus 1. I'm going to take the identity that I wrote up on the right-hand side and I'm going to solve it for the tangent squared. And I'm doing this by subtracting 1. And now I'm going to replace tangent squared theta with what it's equal to, which is secant squared theta minus 1. Okay, now at this point I have students who will cancel incorrectly. If you're canceling at this stage, you're doing it wrong. The only way to cancel with fractions is if you have like factors. And so what I'm going to do next is I'm going to factor the secant squared theta minus 1. And I'm going to write up on the right-hand side the factoring pattern that I'm using, which is a squared minus b squared. It's a difference of squares pattern. And that factors is a plus b times a minus b. Okay, so the secant of theta is, if you're looking at that difference of squares pattern, the secant of theta is the a, and 1 is the b. So we're factoring this as secant theta plus 1 times secant theta minus 1. And that's all over what was already in the denominator, secant theta minus 1. Now once I have it factored, I can cancel. And so that's the next thing I'm doing. I see that I have a like factor of secant theta minus 1. So we're canceling. And what we're left with is secant theta plus 1 over 1, which equals secant theta plus 1. Okay, now you might see the secant theta as being 1 over cosine and continue from there, and that is absolutely fine. But what I'm demonstrating in this video is how to work with both sides until they look the same. So I've worked with the right-hand side and I've simplified it, or made it look different anyway. And so now what I'm going to do is I'm going to work with the left-hand side, which is 1 plus cosine theta all over theta. Over cosine theta. And I'm going to break this fraction up because I'm looking down at what I got to working with the right-hand side and I see what it looks like. So that's why I'm trying this. So I'm going to write it as 1 over cosine theta plus cosine theta over cosine theta. And 1 over cosine theta is equivalent to secant theta, and cosine over cosine is 1. And now I've shown that the right-hand side and the left-hand side are actually equal, and so my proof is what I call a U-turn proof. And at that point, you can just write an arrow that shows that those two are equal, and so we could continue to follow the steps back up.